Hey guys, thanks for coming to the Amazon SageMaker this session. You'll learn about how to build a modern lakehouse architecture, kind of going from your existing data lake architectures. I'm Sandeep, I'm product manager of Lakehouse.
Hi folks, I'm Purvaja. I'm on the engineering leading the SageMaker Lakehouse catalog and lake permission governance.
So the agenda for this is we want to talk about the evolution journey, right? Many of our customers are still on the data lake, existing conventional architecture, but they are looking at the lakehouse as their new architecture. And there are basically three architecture patterns that we want to cover in this talk. One is the unified access. You have the data in a data lake, warehouses, and multiple data sources. How we can use federation as the architectural paradigm to achieve that unified access across multiple engines. Second is with this large data sets, you have metadata that gets really large and you have data that gets really large. Scaling of the metadata and the catalog organization is a key part of scaling your lakehouse, right? So we talk about that performance and scaling for storage, query performance, and more. And then the security is number one for all of us, right? So the governance is the key cornerstone of the lakehouse, and we'll talk about that as a foundation. And all this brings together with the SageMaker offering that we launched, and we'll go over about how you can actually get started with the lakehouse with SageMaker. So we all know that the unified data management is hard, right? You have data stored in the data lakes, you have data stored in warehouses. Many of those data lakes are petabyte style, and then you have purpose built stores, right? So you may have data in the DynamoDB, or you may have data in Salesforce for application specific. And in some cases, you may have to kind of get the data from one data source to another data source. So getting that data across different data sources while you have a large number of data and managing that is hard. And particularly when you want to analyze the data across multiple engines, right? So think about you have these multiple data sources, and on top of it, you have multiple set of engines, right? You want to use open source popular engines like Spark or Flink or Trino, right? These are the engines from which you want to analyze the data process. And so the key criteria comes in is you don't want to lock in to some proprietary format, right? You want to enable it across multiple engines, across multiple sources. And the requirement that we are hearing is, I want to share the data. I want to share data across account. I want to share data across region. I want to share it across cloud as well, right? And those kind of requirements require us to be open format flexible, right? And that's where the key aspect of getting into Iceberg comes into picture, right? And that's where many of the customers start their evolution journey from the current architecture to the new lakehouse architecture.
Yeah, so when we really look at the modern lakehouse, right? Lakehouse is becoming an ancient concept, right? Like, so we're all like kind of redefining what that really means. So your traditional data lakes was just, hey, more of decentralization. I have data in a disaggregated storage. I have compute. So I really have like the whole decentralized architecture, which is all separately elastic that can scale. But now we are getting into the world of like, hey, I want to not just store the data, but I want to use them efficiently. So that effective and efficiency becomes a key. So that means really like folks are looking at bringing back the age-old goodness of all the warehouse back to your data lake economics, right? Like that's really where like you are seeing the real merit of Iceberg and bringing all the transactional goodness to it. And this is really where like, when we think of Iceberg, right? Like not just Apache Iceberg. If you think of the actual iceberg, there's more to the base than what meets the eye, right? Like, so that means like we want to get the data foundation right. Like there are a lot of fundamental things that we want to get right. And at AWS, that is multi-fold, right? Like when we think of Iceberg table format, we have plethora of analytic offerings, right? Like analytic and warehouse offerings. So there is a native first-class integration with Iceberg tables on all of these engines. That means like separate engine query-related optimizations to like, work effectively on your data sets. And then lake formation acts as a consistent governance layer, completely compatible with your Iceberg tables. And then we are having separate layer of storage optimizations that, as folks are aware, like starting from table optimizations, table management, to like how can you still continue to like evolve and enhance the data layout that enables the query planning, query execution to be much more efficient. And that's really where like we bring some of the age-old engine goodness to the table to see like, hey, how can you leverage some of the database goodness, be it around views or materialized views or caching and other enhancements. How can you bring the goodness of all the worlds to the table and still give a unified offering such that it is still like very open format, open catalog, but you have this lakehouse offering which is differentiated. So first and foremost, when we think of again, a lakehouse, right? It's really about discovery. First, you want to get assets from your diverse sources. As Sandeep was earlier showing, right? Like every customer data journey is complex, evolving, right? And for your business use case and needs, you have data in diverse sources. So it could be literally from your choice of traditional relational data sources like your MySQLs, Oracles, and Postgres, to cross-cloud platform like Snowflake and BigQuery and Azure, to other traditional I would say specialized big data platforms like HBase or Kafka and DynamoDB or DocumentDB and whatnot. So you have data literally diverse, right? And that is really the nature of every business, right? So in modern architecture, what customers are now seeking is hey, I do want to be able to have a single pane discovery. I want to first, when I think of a lakehouse, I want to be able to bring all the assets cohesively in a single place. And that's really where AWS historically had pioneered in zero ETL. I shouldn't say historic. I would say probably in the last couple of years where it's a high throughput. There's still a source and target, and it's more of replicating the data from source to target. The new paradigm that is out there, again, it's not a very new paradigm, but it is evolving, I would say, is federation, right? That means you're real time bringing in with zero copy, but you're bringing into the lakehouse the information about your source. And that means you're getting a single pane view of all your technical metadata. So when we think of all these data sources that are exposed through federation, first a schema federation. That means you're able to get an understanding of the layout schema. That means your columns, partitions, all the technical goodness of your data. And the federation can extend beyond to credential federation. That means you talk to your source and understand where your data resides and how do you get access to your data. And it can go to things like even query federation. That means you can do efficient push downs to the source, which is capable of handling the data more efficiently. And the paradigm is more open that it can extend to something called policy federation. Like when you want to talk to a data source that has its own definition of policies and primitives and securable objects, how do you exchange those? So this federation is really setting the foundation, and we at AWS use that as a powerful tool. And how we see the synergy with Iceberg is that as we've been hearing in various talks, right? Iceberg is a specification. It's laying this platform of hey, we will standardize on an open format, and that can actually become the protocol and language for exchanging all this metadata through federation, right? So we are also evolving our federation to standardize on Iceberg protocol. And the other goodness is once you bring these assets, this is all these assets in the lakehouse through federation, think of them as your runtime connectivity to all these sources. But there is also now a common API access. Our lakehouse catalog is completely Iceberg REST compatible. So that means we have a REST endpoint. And all these assets are now available for engine consumption and for various analytic and dashboarding use case through standard common Iceberg REST interface. So you have a common API access. So this means whether you pick your choice of AWS 1P analytic engines, or you come in with your choice of 3P engines, you can really use traditional off-the-shelf Iceberg connectors, connect to this lakehouse catalog, get a single pane view to all your technical assets, and can, again, depending on your use cases, start getting more efficient push downs and get access to your data. And everything will be surfaced as an Iceberg table. That's really the vision of this unified access through federation.
So at reInvent, we launched Amazon S3 table. Right? That's the first cloud object store with the full native Iceberg compatibility. Right? And with the lakehouse, now you have single click model to connect to any of the analytical engines. You just go to S3 tables console, you click on the enable integration button, and the lakehouse enables accessing those S3 tables across multiple engines. You can go, Bob can go and use his favorite engine, which is Athena, and run the queries on S3 tables. Charlie can go use the Redshift and join the data from the S3 table to the Redshift. Or Duck can go and run the Spark engine using Glue and kind of process the data from the S3 table along with Redshift and along with the Iceberg table that is on S3, right? And all of these are governed and secure by the permissions that are set by the lake formation grants that the lakehouse enables. So with a single click, you have these sources available to multiple analytical engines and accessible to it without you having to kind of go and set it up multiple things at the same time. We'll go into the lake formation, the grants aspect a little bit more in the detail on this. But the aspect that we want to also talk about is the catalog organization, right? Which is, you want to cover?
Yeah, so as we first bring all these assets into the lakehouse, right? The next thing that we believe is critical is how do you truly democratize this data for secure access, right? Like that means you want to be able to give some nice organization of these data such that you can start doing data sharing, you can build your complex data mesh architectures, you can have your use cases of like, hey, now I want to be able to, I have brought all these assets into my lakehouse. I want to enable different lines of businesses. I want to be able to like securely share them to different organizations, different LOBs. It could be like even my marketplace like scenarios where I want to be able to share the data securely outside the organization. So what becomes important is what is that ontology? How do you really want to structure these assets? And that's really where like, we are evolving this concept of multi-catalog. What that really means is your lakehouse catalog is like, one Uber umbrella, inside of which like all of these data sources or however you want to organize that data, that becomes like a sub-catalog. And within the catalog is your classic namespaces and tables. So if you're from the database world, like it's also very well aligned with how engines talk to the catalog, right? Like you have your classic three-part like catalog, namespace, or database and table, right? Like you have that nice three-part notation. But what this structure really gives you is a powerful ability to organize your assets in kind of a business use case. Now you can really start thinking about data as a product and start giving that domain isolation. You can define like how your multi-catalog structure should be, and you can start defining the different levels of nesting. So in an Iceberg specification, that's what the good thing about Iceberg is. It's a spec, right? Like it really gives you that openness of like, hey, you can have a concept of multi-namespace. So it is very synonymous. Like if you really think of how you want to plug in your products and use cases, it gives you this nice abstraction of, okay, now I can start consolidating my assets, my different data sources, my workflows and use cases into this multi-catalog structure. And then you can actually start defining how you want to define access controls and governance and enable like, complex mesh architectures and data use cases. So this is really giving you that domain level isolation, but also gives you like, a much more scalable governance. I want to switch gears here a bit and talk about, okay, so we spoke about like bringing all the data into the lakehouse catalog through federation. And we spoke about, hey, okay, now I've organized all my assets. So what is the real story around like, hey, Iceberg table format, great. It gives that, unified interface and open API access to your choice of engines. We are also looking at it from the angle of like, hey, okay, we at AWS want to constantly invest in scale and performance. We want to be in a place where we are understanding different styles of workload, because it's not just your classic analytic workloads, right? Like we are at a point where we are saying we want to build data warehouse style use cases also to a lakehouse, right? Like your traditional OLTP style queries, like, you have really low latency requirements, right? Like, and there are classic analytic workloads where you have high throughput requirements. So we are bringing the best of all these worlds. So just to kind of lay out, like, what are some of the foundational blocks that we constantly think and keep evolving on is some of the core foundation of our metastore, right? Like this lakehouse catalog originally, like, we were a Hive compatible metastore. Like every player out there, foundation was a metastore, Hive-based metastore. So at AWS, it's a serverless offering. So a natural backend is a scalable, distributed, NoSQL style database, which has its auto-scaling capabilities and metadata sharding. And because Hive is partition heavy, most often, like, you have like really large number of partitions, and how do you want to effectively handle those? On the server side, like, your metastore should be capable of doing partition pruning, like building efficient partition indices. We also want to be able to expose all of these Iceberg tables through our Hive interface as well. Like, that's how our catalog originally started. So that means, like, we needed to have like an optimistic locking mechanism to handle these Iceberg tables through our traditional RPC Hive style interface. So if I look at the service architecture, there's a storage layer, which has its own version control, how you do the metadata sharding. And like in any distributed system, like, you want to be catering to different low latency workloads. So multi-layer caching, predictive loading, consistent hashing. And of course, being a serverless architecture, some of the design paradigms that we follow at AWS is that you have a fleet of nodes, and we are regionalized, present globally in multiple regions, right? So you have a fleet of nodes, and you have a load balancer through which all the requests come in. So you have to do all the goodness of connection pooling, request batching. How do you handle the asynchronous requests? So what I'm really getting at here is, those are some of the foundational blocks we build the metastore on. And again, to handle, like, making sure there are no hot partitions, you have to enable, like, we have inbuilt smart replication, like, making sure there's no hot data or hot partition, and then lazy loading, right, coalescing, all the classic distributed architecture goodness that you have. So that's really the core of our metastore. And it started, like I said earlier, it started as a Hive metastore, which has compatibility to all the Iceberg tables as well. But we were providing it through the Hive interface, right? Like, and then we started expanding it into this Iceberg layout on top, right? So that really means, like, now your metastore is becoming really like this efficient storage lookup. Like, it's a very interesting circle, right? Like, we started with, like, hey, okay, I have this full-blown metastore for Hive, which is fully partition aware, which has all the full-blown metadata. Then with Iceberg, we went into a model of saying, like, hey, put all the metadata into the Iceberg, right? Like S3. Like, that's really where, like, your storage layer is, where all your metadata is placed. And now we are getting to a point where, like, I still want to keep some lightweight catalog so that I can still do some effective caching, lookup, and it can become a place where I can do additional things like, manifest caching, metadata caching, do some parallel processing. So it's like, you still want your metastore to work efficiently. You have part of your metadata in S3. You still want to have a lightweight metastore, but still bring some of the goodness there so that you can handle, like, high throughput, low latency workloads. And that's really where, like, we are constantly investing in initiatives like, how do you do more efficient storage optimizations, like, that are closer to S3? Then what are the things that we can do better at the catalog metadata layer beyond just storing the location of where your metadata files are? We do a lot of manifest caching, and we want to do parallel processing and so on. So that's really, like, we believe are, like, some of the throughput enablers that we are constantly working toward.
So we talked about the performance and the scalability of using the metadata architecture that we proposed. The Iceberg brings additional nuances, right, where we have to look at the storage performance as well as the query performance. In particularly in Iceberg, it's a transactional data lakes, right? So anytime the changes are made, even if when you have like a small delete or update, it creates a new files, right? It will create a new data file with the delete in it. It create a new metadata files. It will create a new snapshot. We have seen customers who are saying, okay, I have thousands of snapshots getting generated every day with the set of metadata and data files. What do I do with that? And sometimes if they don't do anything, their query performance drops, right? So apart from all the things that Purvaja talked about in terms of kind of improving the metastore performance, we offer a set of capabilities that improves the storage as well as the query performance, right? So customers can go in the Amazon S3 and have the Iceberg tables and configure to have the compaction, snapshot retention, orphan file deletion. These are some of the primitives that we provide for the Iceberg table. That means as the table changes, as the updates are made, automatically it looks at, okay, you have this set of small files. I'll go and compact it so that when the engine like Redshift and Athena goes and queries it, it doesn't have to kind of open up these thousands of small files. It has a compacted file. If you have the set of snapshots are there, every day getting created, and you don't need all those, it will go and remove the things which you don't use and not get referenced as orphan files, right? So it manages the storage for you. So you have clean set of data, even though your data is still transaction oriented, you have the clean set of data and metadata that with which you can have a higher query performance. The other set of metrics or the statistics that our query performance or the engines need is the Iceberg statistics, right? So the engines like Redshift, Athena, they come with what is called cost-based optimizer. That means you run a query, and let's say that query has multiple joins. The query plan decides whether you join table A with table B or table B first with table A, right? The join ordering makes quite a bit of difference in terms of what is the output and what is the next table you're going to join. And that all depends on the cardinality, which is the NDV is one of the statistics that the cost-based optimizer need to define that query plan. So you can have the best possible query performance. And so with this, we generate Iceberg statistic, which is the NDVs automatically for the tables. And so that we're seeing that the Redshift and Athena performance can be dramatically improved. And with the ST tables, you don't even have to worry about all that, right? It comes by default. So all this is built in table management with the ST tables. Your tables are already getting compacted. They're already managed with the snapshot retention unreferenced file. So here you don't even have to worry about any of these primitives or setting it up or configuring it. And there is a lot more things that we will put it as part of the built-in table management over the next few months. So we talked about unification using federation. We talked about the performance scaling, query performance improvement. The security is number one, right? So that's the biggest thing that when customers talk to us, they say, okay, I have these set of data. I don't know what to do with these set of data when I have to apply multiple engines and I have to give access to multiple business analysts or data engineers or even business users. So then they are looking for us on providing the flexibility of governance patterns. And the governance patterns would be, RBAC, TBAC, ABAC, multiple of the governance, fine-grained access control. So there needs to be a flexibility of how you can apply the permission model at scale across all these data sources, and an ability to add additional data sources going forward. Right? So these are the data lake permission challenges. So we think governance is the foundation.
Yeah, that is very true, right? Like governance is now becoming a first-class citizen. Like with more and more data, be it your generative AI models accessing or your agentic AI is running, like there's more data accessible to a lot more people in the organization. And there is more onus on like the data domain owners or product owners to understand and define how they want to securely give access to this data, right? Like that's where I keep stressing, like you truly want to democratize the data, but yet have the control on clear auditability of how the data is being accessed and read, right? So that's really where, like we say, like governance is now a first-class citizen. That means like, hey, okay, let's come back to the premise, right? Like I have my lakehouse. Okay, great. I have this open API access layer through Iceberg. Great. Now this lakehouse catalog is exposed as a REST catalog. I have access to this all diverse resources. So I have the single pane discovery, whether you're hooking up your Hive compatible sources or your external cloud and other transactional sources and surfacing them as Iceberg tables or native Amazon owned, like, AWS S3 tables or other generic format data sets in your native buckets. So you have all these assets, right? Now, what we really believe at AWS is, okay, governance should be simple. It should be something that you can understand, but it should also be powerful enough so that you can define, it's like a toolbox, right? Like you can define as companies, compliance policies are evolving, right? Like you think of DMA compliance or like, GDPR, CCPA, like new compliance requirements are constantly coming up and evolving. So you want to be able to have a governance layer. It's like your toolbox where you can start defining complex policies and yet have clear auditability on who has access to what resource. So now when you have better organized your data into the earlier showcased organization, say in a multi-catalog structure where you have your catalog, namespace, tables, and so on. So first is primitives that are really fine-grained. If you care about hey, I want to be able to control the data access at a table level, column level, row level, cell level, so you can really slice and dice your data access depending on how where you track your PII data, at what granularity you want to give access to, so you can define fine-grained access controls. And then we also heard that hey, okay, as more data sets come into play, I don't want to get into this land of proliferating all these grants and policies because there's just too many principles, too many resources. When we are really thinking about the permutation now, it's just leading to proliferation of grants and management. And that becomes an operational hurdle. So that's really where we build primitives like tag-based access control, attribute-based access controls, role-based access control. Again, these are, think of them as how do you really want to define your ontology on your resources? How do you want to define your attributes, key and value for your incoming principles or request context and so on? And you can define your policies based off of that. In fact, in the year or so's reInvent, I think last year's reInvent, right? A year before. We did open up multi-catalog views, right? Like what that multi-dialect views. What that really meant was, now we will give you full-blown SQL capability to be able to author complex policies. Like if you have a consent table or an entitlement table that you want to be able to look up and define some policies with some complex predicates and so on. So we wanted to give that full-blown capability of hey, okay, then you need a full-blown SQL surface to author your complex policy, be it your DMA use case or your organization's new compliance needs. And why we chose multi-dialect is, again, if you look back at the Iceberg view specification, that seeded the thought of hey, you want to be able to support plethora of engines there, then we need to at some point get into the weeds of honoring the syntax and semantic difference across different dialects. And we at AWS, more so than other players out there, it's a very common problem, right? It's like double-edged sword. We have multiple offerings, but when you think of a lakehouse and want consistent governance, you still want a single place where you can cohesively author policies, but at the same time have a reliable way to enforce that through your choice of Sparks and Trinos and Prestos and Hives of the world, right? So that's really where we build that primitive of multi-dialect views. And then again, the other primitive, which is close to the governance, is secure data sharing. Okay, great. Now I have this assets. I've defined all the fine-grained access controls. I've defined my policies. I want to be able to securely share the data. And we have different, again, cross-account sharing primitives. It could be at a cross-account level, org level, organization unit level. It depending on how you want to define your data mesh, how you want to define your different lines of businesses and use cases, you can securely share these products. So it really caters to different mesh architectures, whether you have a central pub-sub style architecture, hub and spoke, or whether you have peer-to-peer style. So in all of those models, we have different sharing paradigms. This is just a quick primer that I wanted to touch base on. Again, in all of these, one thing to highlight is all these primitives work seamlessly on Iceberg tables. So all those data sources that you're bringing in, surfacing as Iceberg tables, the governance is agnostic to your underlying table format. We wanted to keep that uniform across all of the lakehouse. And tag-based access control is, again, one of the popular tools out there that AWS offers, which is really if you have complex data pipelines and which is constantly bringing in new data sources, and you don't want to be as going back to the data admin to constantly give access to every single file that is ingested or every single table that is ingested. So that's really where as a data lake admin, the persona can define what is the ontology, right? Hey, what are the different classification of resources that are coming in for my data product, right? Like, so you can define that ontology and say like, okay, this is how I want to classify my resources. And then it's a simple tool of like, defining a key value. That's the tag, lake formation tag. And then you can attach them to the resources. As they are ingested into your ecosystem through your ETL pipelines, you can start associating tags to the resources. And again, like, this follows a nice hierarchical model. Like when we talk about resources, it could be catalog, database, table, column. So you go to the lowest level resource, and then you make tag policy grant. Then you say like, okay, I want to be able to grant access to Alice for all the engineering resources. So anytime a new asset goes tagged with engineering, she gets access. So that's really like, the power of this tool, so that you don't have to proliferate your grants every time a new resource is added to the ecosystem. And something to augment this is really the attribute-based access control. So we spoke about, hey, I don't want grants to proliferate when more resources are ingested. And at the same time, like when more and more principals come in with like, different contexts, with different request attributes and so on, you want like a combination of like, hey, okay, I want to be able to say if a request is coming from country equal to US and department equal to X, like, gets access to a resource that is tagged a certain way. So that's really like, the full breadth of like, how do you combine the power of attribute-based access control and tag-based access control for efficient policy management. And this is just a visual example to saying like, how you can, in this model, like, Ava is a data lake admin who can make prescribe like, attribute-based grants, and then, and once you define that in the ecosystem, whether it's Alice, Bob, or Charlie's of the world, for different use cases, when they come in with different attributes, your corresponding enforcement is taken care by the lakehouse governance layer, and you get access to the right resource. So that these are the powerful primitives that we believe will help in your governance journey. And as we are in this forum of talking about, hey, how do we build open catalog, open format support, and so on, we believe like, our lakehouse strategy is also like, we do not want to lock customers in any ecosystem, right? Like in this model, we are still very much supportive of the fact that you can bring your choice of your meta store, you can bring your choice of the catalog. And again, like, through a standard spec and interface, we are able to like, connect to those catalogs through federation. And then you can also bring your choice of governance tool, right? Like just to name a few, like say if you have Purvaja or Immutas of the world as your choice of policy store, you can hook that up with our lakehouse, lake formation layer, and you can bring those policies into the lakehouse catalog. And then you can get still a consistent governance through your choice of AWS 1P engines or other 3P engines. And if you're really talking to the REST interface, then any 3P engine with standard Iceberg connector, you should be able to still get all the capabilities.
Yeah, so we looked at the three architecture model, right? So the models of unification with federation, the model of scalability and performance, and the model of security governance. How it all comes together. We launched the SageMaker, next generation SageMaker that brings data, analytics, and AI together, right? So it is kind of continuation of our journey from SageMaker, who was primarily AI-based to now supporting all, right? So Lakehouse is a foundational part of this SageMaker platform that allows you to kind of connect to multiple data sources, get access to the unification of the data, as well as have the performance, scalability, and security. And you can augment that with the additional data, AI governance, and the business catalog. And we provide a large number of tooling within this umbrella we call Unified Studio, where you can go and do the SQL analytics using the engine of your choice, whether it's Redshift or Athena. You can do the data processing, whether it's Spark or others using your choice, again, EMR, Glue, or Athena's. Or you can do the model development, as you have been doing with the SageMaker AI, and bring the Bedrock's GenAI development as well. There are more things that are added almost continuously in the overall SageMaker umbrella. And Lakehouse is a big portion of that. What Lakehouse allows you to do is that layer where it's bringing you the unification of access, whether your data, it could be in S3 data lakes, could be in S3 tables, could be in Redshift data warehouses. Apply fine-grained access control across all this data. And what we didn't talk much about is the zero ETL integration, right? So we have the set of like hundreds or more of these connectors where you can get the zero ETL and get the data from those data sources into the lakehouse or federate, right? Means the data stays where they are, and you push down the queries to run on those particular data sources. So we enable both the set of options with the lakehouse, allow you to kind of connect to and bring to this large number of data sources together as a unified view, which is open, like you can access ST tables or data lakes or Redshift using this open Iceberg APIs, and secure, as we talked about, right? So how do I get started? You can just type the SageMaker in the AWS console and go, and there are a couple of steps you need to kind of go through it. As you set this up, when you launch the studio, there is a portal that comes. And on the left side, you see this is the lakehouse. This is the lakehouse that I have. For example, what you see on the left side is the AWS data catalog. That's your traditional data catalog, the Glue data catalog. You used to have all the S3 data lakes and your databases and tables together. Now you can see that you have this DynamoDB, right? These are my tables in the DynamoDB. You have the MySQL DB, right? So these are my databases and table in the MySQL. You have Redshift, Postgres, and now you have the ST table, right? So the newer things that we launched, which is organized by the catalog, namespace, or database, table. And the great part of it is on the right side, you see that you can start querying it using any of these engines. So you can say, okay, I want to find the data from the ST table, and I can just query it using the engine of your choice. Or I can join the data between these two tables and extract the insights from it, right? So this allows you to kind of get the unification, get the scalable engine support, at the same time making sure that it's secure. So whoever is using it only get access at a fine grained access level, what access he has. So closing thoughts on this. We really double down Iceberg with this, right, with the lakehouse. And there have been several things we have made in terms of kind of providing the Iceberg compatibility through Iceberg REST catalog, supporting the Iceberg set of maintenance, and even launching of the ST tables and supporting the ST table through the lakehouse. What we are looking for is more of community participation and collaboration. We're seeing that our engines, for example, Redshift and Athena, can benefit if there are advanced statistics. Like, for example, current specification of Iceberg spec for Puffin supports NDV, which is great, right? We have seen the query performance improvements 60% or more with those just with NDVs. But then there are a lot more advanced statistics, right? That query engines can use that include, your histograms, your MCVs, a lot more. And so we are looking for ways where we can do our contribution to Iceberg community, work with you guys, and have those part of the Iceberg spec so that everyone benefits. We have the query engines who can use it and perform much better, and we can have the advanced statistics that's automatically generated for the Iceberg tables.
Yeah, and just to close out, right? Like I know we're at the top of the hour, so we are really looking for thoughts on, as we speak about governance. And I think in the earlier talks also, Jason mentioned that how do we have a common standard exchange primitives, securable objects, like policy metadata, as we think about governance. And we've also collaborated with the community on query planning improvements, like the pre-plan and plan APIs, like how can we get better query push downs, like how can we extend the Iceberg expressions to support more. So these are some of the areas where Robbie would love to connect with you offline and collaborate. With that, I guess.
Thank you. And these are the few blogs that are out there. These are detailed technical blogs where you can go and kind of recreate lakehouse to S3 integration, or the ABAP that Purvaja talked about, how you can go get started on that, or query federation to with MySQL or Postgres. Or if you just want to use the Iceberg REST catalog interface, there's a blog for that. So feel free to try it out. Let us know your feedback, and we are open for any questions you may have.
Thank you.
Thank you. I have an offer. Anybody who asks really good questions to either of them gets that Ubi drink. Anybody who missed it, they were out in 5 minutes. But if you ask a really good question, you would actually get one. So here we go. Good questions.
So I have a question on the governance part. Like basically, you spoke about tag-based access control. So I'm interested in that one. So in tag-based access control, and specifically because on AWS is supported via S3 tables or AWS Glue catalog. So in these cases, I did not notice a way to add. So is the tag applied on the table, like at the bucket level, or is it at the catalog level? Because I would really want to use it, but if I can't, if I
Yes,
don't know where to
yes.
put the tag on, so I don't know how to use it.
Uh, Okay, so all these assets are surfaced on the Lakehouse catalog, which is aka it is like the Glue data catalog, right? Like it will surface. There's a bug we are actively working on, so we'll connect with you offline, and we can connect our product on when we will open the tag-based access control. Yeah, it's currently under the works.
Okay, thank you.